I guess it begins. Welcome to 3D Club, everyone. Well, once again, welcome to 3D Club, everyone. Um, I sort of, just to get the ball rolling here, I had the idea for this episode a couple of months back, and my plan was sort of like to crown one of these programs king, being Fusion, AutoCAD, Rhino, Onshape, and Blender, and realized that getting into it, that you can't actually do that. Each one is sort of better at some things than others and worse at some things than others. And the other thing I've noticed was almost everyone using these programs is using, it's not just using one program, but are sort of dipping into other ones here and there to do like really specific jobs and whatnot. And that kind of like piqued my interest in it. Um, if I guess I'll just introduce everyone who's shown up for this thing. Brett Bailey is going to be doing Fusion. Jamie Roman, who will be doing Onshape. Ian Davlin, who will be doing sort of like a Blender example of stuff. And then myself, I'll be doing Rhino. Mike Brower was supposed to do AutoCAD. He has not arrived yet. Let's hope he does. And what we're going to do today, after we've sort of done a bit of roundtable discussion, everyone's sort of talking about their experiences with 3D modeling and why they're getting into it. We're going to demo this little guy. It is the Spring Collet out of a Fender Vibrato. It seems like it would be super simple, and in a lot of ways it is, but there's a surprising amount of stuff to consider when modeling it. So to get us started, Brett, you want to tell us about how you got into 3D, what you enjoy about it, and what some of your experience with it is?
I got into 3D modeling because I wanted to build guitars on a CNC machine. So I got into Fusion 360, and I kind of just didn't go into any other types of software.
Hmm.
I just stuck with that. And it's been great so far. There's a lot of bugs I've found, but
Yeah.
they continually update it. So about like once a week, once every 2 weeks, there'll be an update that comes out, and things start running a little bit smoother. I'm just hoping that one day it's totally bug free.
Yeah. Are you using Fusion just as drawing, or are you using the cam portion of it as well?
I use it for everything. So the cam, the rendering, and the modeling.
Okay. And full disclosure, I met you in a Rhino class. So
Yeah,
yeah,
yeah. That was the inlay course, and
yeah,
I found the vocabulary between Rhino and Fusion, it's very much the same.
yeah,
Um, I mean, sometimes you got to break out a thesaurus, and then you'll find out like, oh, that's what he means. Or as soon as like Tom was discussing what a certain tool did, it's like, okay, well, that's
yeah.
this tool in Fusion, right?
That's sort of one of the things about this that I found really interesting, was kind of hoping to highlight is the similarities between all of these programs, like how your skills in one program is actually transferable to another once you get sort of the nomenclature down.
Yeah, I think the hardest thing between transferring between programs would be like just learning where everything is,
Yeah.
and how to navigate properly too, right?
Yeah. What would you say are some of Fusion's strengths versus some of its weaknesses?
Big strength is being all in one.
Yeah.
So having just being able to go from design to cam like in the switch of a tab is amazing. Having all the McMaster car components just like on deck, right, like in within the program is really nice. Um, yeah, it's sort of simple to use. It's got some quirks that you kind of have to pick up as long as you go along. It likes to keep you on your toes. But once you kind of get around that stuff, it's pretty smooth.
Nice. Well, I look forward to your Fusion demo in a couple of minutes here. Mr. Rodman, sir, you wanna you wanna give us the skinny on your 3D experience?
Sure. So I'm going to be demonstrating Onshape. Um, And that's the program that I started with even before 3D printing or CNC. I have a lot of manual machinery, and I would typically draw things up and make detailed drawings that I could use on the manual machine. And that sort of thing is really easy in Onshape. I also
Yeah,
find it to be very quick. I'll use Fusion 360 if I'm ultimately going to CNC something so that I can use the CAM components. But if I just intend to 3D print something, I'll do it in Onshape. I feel like I can do it faster. Um, but I agree. I agree that Fusion has a lot of advantages in the CNC realm, including what we were talking about being able to easily thread objects. There's just some things that it has built in that are really easy.
yeah.
Yeah.
Dipping back and forth between Onshape and Fusion and whatnot, and seeing some of the strengths of both. Well, actually, before anything, was it 3D modeling? Was it 3D printing that sort of dragged you into this?
No, I would use it before that because when you're manual machining, it helps to have a technical drawing to
Yeah,
refer to. So I was already pretty familiar with doing basic 3D drawings, 3D
yeah,
CAD. I still feel like the way I draw reflects my manual machining background because I typically will draw things that I know are easy to do on a manual machine. So now that I have CNC, I have to rethink that quite a bit
yeah.
because there's things you can do on CNC that would just be very difficult on manual machines.
That's fair. And what would you say with Onshape? What would be the strengths for you?
Um, well, one thing it's all browser based. That
Yeah,
could be an advantage or a disadvantage depending on what your situation is. Um, I find that Fusion 360 in some situation really taxes my computer, uh, whereas Onshape doesn't seem to have any sort of taxing in that sense. Um, One of the downsides is the license. The full license is fairly expensive. The free license, you're required to have your files be shared with the community. So if you've got proprietary things, it may not be the best option for you. Um, Other than that, I mean, I think that there's a lot of similarities with Fusion 360. It's pretty easy to go back and forth.
yeah. You don't have any issues with files not being compatible and whatnot. Like it's pretty seamless and
I typically don't send files back and forth between the two. Um, I'll generally stick to the one program.
yeah.
Uh, yeah, but you can. I mean, that send send certain files back and forth. Uh, the problem that I have is that when importing files, a lot of them aren't editable in the same way that your original drawing are. Yeah.
Yeah, that's fair. Ian, you want to tell us about your Blender experience? I assume that the 3D printer was the gateway drug for you and sucking you
Well,
into this whole thing.
I actually started out my journey started out in SketchUp of all things. A friend of mine wanted to know if he was trying to figure out how to get into CNC for mandolins, and I was like, well, how hard can this be? And I started in SketchUp, which looking back on it was pretty dumb. But then after a little bit of research, I landed on Fusion 360, and I spent a lot of time in Fusion 360 early on. And so I'm probably still like Blender is the one that I've been like going hard on most recently, but I'm still probably apt to start things in Fusion 360 and then finish them off in Blender for whatever I need that I find irritating to do in Fusion. So
Just for the sake of example, like what would be something that you would take to Blender as opposed to Fusion?
well, so anything that requires texturing or anything like that, like anything that is outside of like, anything that would be an organic shape, I feel like, Blender can do a lot better. It just straight up it has a sculpting suite in it. So if like you wanted to sculpt the bust of Jeremy Borcat or something like that, you could totally pull it off.
And who
Um,
wouldn't?
and down to the individual whiskers. So and that's what it's for. Blender is for, is for it's for CG, it's for computer graphics, and to a lesser degree VFX and stuff like that. But so it's kind of a different animal. But I find it to be very handy for quick shapes. Like I find it to be, like if I'm going to import an image into something like, like you might take a picture of a bridge plate and you want to make some calls for a bridge plate. I'm probably going to do that in Blender before I do that in Fusion, just because it's just very quick to pull shapes into shape. So, like, and I can show that
bridge
later,
plate?
but
Damn, Jeremy.
But
Well,
as you'll see, we're going to run into we're going to force Blender to do something today that it's not really designed for. You can force it into these things, but what we're going to do is a prime example of something that I would start and because it's so simple, I would probably start and finish in Fusion. It would never go into Blender. But I do have a project that we can look at that will show kind of like what I would do in Blender. So
fair enough. Well, I mean, to full disclosure, Ian and I have dry run this thing in Blender a handful of times, and each time was a pretty interesting experience.
I'm trying to model it in Blender like Blender is designed to model things.
Yeah.
So and yeah, so
There were aspects of it though that I will admit were pretty both intuitive and sort of quick and easy, much easier than the roundabout ways that you would have to approach it in Rhino.
For just pulling shapes, like that's what it's designed for. It's like, if you're building a car, you start with a rectangle. You cut the rectangle and you pull up the roof. You get you do 4 wheels. You want 4 wheels all the same size, you just duplicate them, or you can array them or something like that. And it's super fast for making shapes. So it's not super fast for making those shapes super accurate though. So that's the crunch. That's the trade-off.
Well, I think at this point be a good time to start doing some actual drawing. Mr. Roadman, sir, would you like to be the first one? You want to share a screen there?
Yep.
Sort of walk us through your process.
Can everybody see that?
Oh, you're already done.
Yeah. It's cake.
I vote for Onshape. Look at this.
Yeah.
Just open the window and it's
All right.
Preloaded.
Well, I thought it would be good. We could all, look at the part before we start modeling. So what I would do, I'm going to create a new Art Studio. Okay. Start a sketch. I'm going to do it on the top plane. And I'm going to view normal to that plane. Okay. I'm going to start by making the circles for basically all the features. Okay, so we have an external dimension of 0.590. And then 0.400. We have 2, 3, 4. And then okay, and I'll pull all these out so it's clear what we have. Okay, at this point I want to extrude our shape, and I know that the little flange here, I'm going to select it and hit extrude. It shows you the direction that it's going to go. It always starts at 1 inch.
Mm-hmm.
Okay, and we want it to be 80 thousandths. Okay, and I'm prove that. I'm going to go back to the original sketch. Okay, and I'm going to select those two features I want to extrude as well. What do we say? We know our overall height 0.43. Okay, that's our basic shape.
Mhm.
And then I need to go back and make the recess. So I'm going to go back to my original sketch. I'm going to grab that section that is going to be recessed out. Is that what I have? What did I say? It's the 0.23. Oops.
Do you have this set up to automatically give you annotations every time you draw something, or does this just do it on its own?
It just does it. There are, I think there's features where you could turn that off, but it's standard. Okay, so
I like it.
what I want to do is I want to extrude that, but we have it there when we don't want it. So I'm going to make it a remove. It flipped it around. I really did want it to go that direction, so I'll flip it again. But we don't want it to go all the way through. We want it to go 0.245. Okay, and now if I look, we have our recess. And then the last thing to do is to put the chamfer on the top. And up here, there's a chamfer tool. Select that, select your chamfer. Okay, it already has 2 distances, which is what we want. Let's see, we want it to be, why is that? Okay, so we want it to be 0.045 the top and 0.080. Oh, did I get that right?
0.031 for your distance on the top one, I believe.
Is that right? 0.031.
No?
Oh, I'm sorry.
No, 0.31. Sorry.
I think that's right. So this is distance in. Hang on 1 second. Maybe I have it backwards. Yeah, that's what I did. I had them backwards. Does that look right?
That looks perfect.
Yeah.
Now from there, just for curiosity's sake, if you were going to try to cut this or print this, would you have to join all of these surfaces together?
No. So if we go back and we look at our original extrude, we have new right here. And then for the second extrude, it's add. And so that's going to join to an adjacent shape. If you're adjacent to 2 other shapes that are separate, it will then ask you, see down here at the bottom, it says merge scope.
Yeah.
So it's going to ask you which shape you want to merge with. But since we only had one shape, it just intuits that that's what you want to do. And then our final extrude, we selected remove.
Yeah.
So that makes the cavity.
That's actually pretty neat, though, the fact that it just automatically sort of assumes that all of these pieces will be joined together and whatnot.
Yeah.
Rhino, you're constantly selecting and typing join and whatnot.
Yeah, the intuition is really pretty good in the program.
Neat. Any sort of tips or tricks? You've done this a couple of times now. Anything you recommend doing to go through this? Like I noticed you did a chamfer for the top, whereas, I suppose like when I did it in Rhino, I mean, there is a chamfer option to do it, but I ended up just doing sweeps around the edge and removing some stuff.
Yeah. Yeah, I don't use sweeps all that often. Probably going back to the fact that I have a manual machining mindset when I'm going into it. But yeah, no. I really probably wouldn't know how to sweep that very easily. Yeah.
As far as threading it goes, is there like an easy function in Onshape to thread like
Not
Fusion, or do you have
not
to
the,
import something and do a cut?
the last time that I tried to research how to do it, I don't know if they do update this pretty frequently, so I don't know if they've added anything. But when I originally looked at threading, you had to actually dimensionally make a helix, and it was just really complicated. Whereas in Fusion, it will intuit based on your hole size, what you likely want to do.
Yeah.
Uh, so yeah, if I was going to try and thread something, I would immediately go to Fusion.
Yeah, through Rhino, I've ended up having to thread a couple of things, and it was either like taking something from the McMaster-Carr website and cutting it out of the object I'm looking to do, or building a helix and doing either like a sweep one or an array around said helix, and that involved building a shape to array and all of that stuff, and it was super not intuitive or fun.
Yeah.
Time consuming to
Yeah,
say the
for sure.
least.
Yeah.
Awesome, man. Well,
All right.
thank you.
Sure. No
Brett
problem.
Bailey, you
Can-
want to take a crack at Fusion here?
Before you proceed, can I ask a question? Just a
Yeah, sure,
general
Doug.
question. The programs that you're showing off, like the one that Jamie just showed off, which I don't even remember the name of.
Onshape.
What was it called?
Onshape.
Oh, I thought you said Dante, like Dante's Inferno. Onshape, okay.
It's just like
My question is this: are these the programs you typically are used to working in? Like Jamie, is this the program you work in for your 3D stuff, as
Yeah.
opposed to choosing another one of these programs? So these are all the programs that you guys favor when you're doing your stuff, typically.
Yeah. I typically favor Onshape if it's something that I'm going to 3D print and it's a relatively simple shape.
Mm-hmm.
I find that I'm faster at it. If it's something that I'm going to CNC, I'll use Fusion 360, particularly if something has a thread in it. But you can 3D print. It's easy to export a 3D printing file from Fusion as well. So I have to plan ahead a little bit.
That's more of an answer than I even understand. But I just wanted to get the idea that these programs are the ones you're typically using for your day-to-day work that you're showing off.
Yeah.
If I could interject really quick, Doug, if you're wondering, like, is this like learning a computer language? Like, if I spend all this time learning this, am I hosed and, do I have to relearn everything? There's maybe a little bit of that, but what I've never used Onshape in my life, and what Jamie just showed me there did not perplex me at all, coming from a Fusion 360 background. So the intellectual barrier to entry, jumping from program to program, with the exception of maybe Blender or when Mike comes in and does AutoCAD, is not like there are moves that have been kind of standardized between the different programs to a certain degree, it seems like. So
Okay.
maybe Jamie can speak to that better, jumping between Onshape and Fusion 360.
Yeah.
So the general mechanics are the same from one to the other. It's just the difference between using, Excel versus some other D-based program or something like that.
Yeah.
Gotcha.
once you sort of get your feet wet, Doug, and you start dipping into one of these programs, like you'll be able to take a lot of that and apply it to other programs. So if you try out Rhino or something and it just doesn't click for you, like the stuff you would learn in Rhino, you can take to Fusion. And though it might be called something different in their toolbar, at the end of the day, all of the tools to a certain extent are kind of the same.
I get you. Thank you.
Yeah. All right. Brett Bailey, you want to give us a little walkthrough in Fusion?
All right. So, can everybody see my screen?
Saw that earlier. It's looking mighty nice.
All right. So, let me go full screen. So I've just opened up a new drawing. In document settings, I'm going to go new component. And I'm going to hit OK. I'm going to do a sketch on that plane. I'm going to plop it right in the center. Now I'm just going to start with all of my outside diameters. So I'm going to extrude them all up 80 thou, and that gives me the bottom layer. It's hid my sketch, so I'm going to pull that back up. I'm going to take my outside, I'm going to bring that up to the 80 thou, and I'm going to add 265 and change from cut to join. I'm going to do the same thing for these inner. So up to the top, I'm going to add 80 thou this time. Wow. Join that. So this is just an example of making solid bodies. I'm going to switch over to surface. I'm going to do a loft from that edge to this edge, and that's going to give me my chamfer. I'm going to go ahead, I'm going to hide this body. Actually, sorry, I'm going to hide this body. I'm going to do another loft from here to here. And what that does is that just gives me thin walls, which then I can loft this to there, and I can stitch it together. And that'll give me two bodies, which I can then go back to the solids tab and combine. And then with this, I'm going to extrude that all the way to the top. And go back in here, cut my recess out of the bottom. 265 thou. I'll go to my threading tab, and I'll pick my thread. I'll hit A. It'll bring up my rendering on brass. And just throw some polish on it. And that is modeling in Fusion.
I gotta say, throwing that thread in there so easily, like that is just fantastic.
Yeah, it's awesome. And then if you wanted to, rather than going back and like remodeling things, you can just go to your parameters and open up your sketch or your sketch parameters. Say if I want to make this 600 thou, it just widens it a little bit. Let's do something more drastic, like, I don't know, 2-inch, right?
Oh my God, that is amazing.
Yeah. And then the reason why I made it components, I'm going to go ahead and save this vibe. The reason I did it as a component is because I can go in here and I can insert a drive, find that file, and then click on component or click on the component, hit OK, and then it'll load it in, right? And since I'm going to move it out of the way so it's beside it and hit capture position so it stays. Since it's it started out as a component, all of the sketches that go with it are brought in along with it. So then I can do that same thing in the change parameters. And that's like in a whole nother sketch. So like if I'm doing a guitar file, I'll draw like my body, my neck, and the fretboard, and then I'll save it and as components, and I'll derive that into like a machining file. That's separate from the design, so nothing like moves around on me if I make any edits, you know. And it keeps everything pretty airtight. One thing I love about Fusion too is its like its organizational features, right? Like you have just every, I don't know, just layers and layers and layers of folders that you can build within it.
Yeah.
Um, and then like the McMaster car stuff too, where it's like literally you can log in, add stuff to your cart without even leaving the program. Oh, I don't want that. And just loading in, I don't know, say just a random screw or thread. So yeah, it's like just loaded in directly off their catalog. I don't have to leave Fusion to do that sort of thing.
Or have multiple windows open.
Right. And then, just going, jumping over to manufacturing is as simple as that.
Yeah.
And then, yeah, the rendering workspace is pretty great too. I haven't played with any like third-party textures in Fusion. I also don't really believe Fusion is the program to do rendering in. I
Really?
think, yeah, I think there's probably something better for it. I don't know. Some of these texture packs are like hundreds and hundreds of dollars, and it's like it doesn't really make sense.
Yeah.
There's got to be something out there that's like just better.
Would that something possibly be Blender?
I think it is.
Blender's really good at rendering. Not
I've
gonna lie.
heard. I've never played around with it, so I'm excited to see it.
Yeah, we can do some rendering stuff. For sure. So the thing about Fusion is the difference between NURB modeling and mesh modeling.
Yeah.
Mesh modeling is definitely more geared towards rendering, although we can get into that in a little bit.
Brett, when you're doing stuff of this nature, like, are you part of the Ticket Two Guitars school of thought, like Ben Kaler, who before he even builds a guitar, before he does his assembly and starts buying parts, he's actually modeling and 3D printing everything and then testing to see if it fits and works before he places his McMaster car? Or,
Um, yeah, in a sense, like, so I've designed like some jigs, um, like this clamp here, and this was something I designed fully and got all the master car parts into it before I even decided to prototype it.
yeah.
Got shit there. You can see it on my Instagram if you go over there.
Yeah, for those curious, Brett has a second Instagram outside of Contriver Guitars called Bailey Instrumental, that is sort of more geared towards the jigs and fixtures and whatnot. Would you say that's the correct assessment?
Yeah, jigs, fixtures, guitar design. I'm gonna get into selling wood for like guitar tops.
Mm-hmm.
Uh, yeah, it's to separate my guitar line from all the other design work that I do. Yeah, so for like guitars though, like I'll fully hold on, let me find one that's actually modeled up. Yeah. So I'll fully design the guitar out and then take it into a separate machining file. And then everything's like planned out as much as I can before I start building.
Mm-hmm.
I'm sure everybody does that though. As far as prototyping though, I'll like test pickup pockets out on like scrap piece of the wood. Neck pockets, I'm pretty confident on. I usually get a pretty good fit every time. Yeah, I mean, it's just getting a hand of tolerances, right, and what you're looking
Yeah.
for.
I was gonna say, like when you're doing neck pockets and whatnot, like do you have sort of a certain allowance that you go for? Like if your neck width is a certain size, the pocket has to be that size, but like 15 thousandths on either side to kind of compensate for the fit, or
Yeah, so for a bolt-on that's getting a spray finish,
Mhm.
I will do about 4 thou of an offset or like zero point 0.1 mil. And
Yeah,
that allows the neck to slip forward out or yeah, forward out of the pocket about an eighth to a quarter of an inch. Which is enough. As soon as you get sprayed finish on that, any overspray that's left in the pocket, you can still get the neck in. But for like an oil finish, I won't do that.
yeah,
And same with set neck. You know, if it's like too tight of a fit, you just hit it with sandpaper, right?
yeah. Cool.
Yeah.
Well, thanks, man. That was awesome. I guess it's my turn to rhino it up. So I'm just gonna share screen here. So I went in a little bit beforehand, and I sort of pre everyone.
Oh, come
everyone
on.
that, what? Think this is cheating, Ian?
Well, I didn't make my circles yet. Go ahead. Go ahead.
So I'm gonna go into my top view and just replicate this quickly. So I'm gonna do circle radius from center. I'm gonna use the diameter function for this. And this first one is 0.59.
If
And
you're doing hotkeys, you should call out your hotkeys.
oh god, that's gonna take some braining. So the next thing I'm going to do, which is something that in learning this program from Tom Dahlia, he told me definitely don't do this, but I've found it actually works really well. I'm just going to dip in and apply a single point to the center, which gives me an anchor point for the rest of my circles. So I'm going to go in another circle, same deal, just holding shift, 0.4, or no, 0.04. No, wait. Yeah, 0.4. And then again, same deal, 0.31. And then another one, 0.23. And then final one is 0.14. And now I'm going to dip out into my perspective view and build what could potentially be an unnecessary structure, but I find it actually helps. So I've picked that point, and I'm going to just draw. I'm going to go down into here into one of the other views just to make sure I've got a 90-degree angle. I'm going to do the entire height, which is 0.43. And now I could just extrude and do the type in the numbers for the extrusions, but I'm just going to add a little extra structure here just for safety's sake. So I definitely need a 0.08. And I'm going to insert a control point there. I need another one that is 0.245. Gonna find the end and the intersection of that, insert another control point. I'm gonna do a 0.08 from the top. And just add another quick control point there. And it's not super necessary to do that, but I find better safe than sorry. So my next step after that will be to extrude this curve. And it's trying to get me to do both sides. I only need one direction. I'm just going to type in 0.08 for my height. And that would be the first tier of this guy. Now I'm going to do it again, but this time I'm going to select this one. And I just need my calculator really quickly. 1 second here. So bring it up to that point would be 0.35. And then I'm going to grab this guy and extrude again, which I did not do. And pull this one right to the top. So that doesn't look like much at the moment, but when I change it to a slightly different view, we've got this shape now. As far as this next step goes, where you're adding the chamfer, I find the chamfer tool in Rhino can be a little funky at times and have had some difficulties with the chamfer. So the way I've done this process is I've gone in and I've used a command called dupe edge. And I'm going to grab that and that. And I'm going to hit enter. And what that has done is it has taken the extrusion and created a matching curve from that surface, both of these. You'll note that I now have the ability to either select the entire shape or just select that. So I'm going to go in with my polyline tool and I'm going to find the intersection in the quad. Went a little too far there. Grab that and bring it to there. So what this has done is it's created sort of the chamfer for me. Now I'm going to go and I'm going to write the command split, because in order to sweep that shape, I got to break it first. So select objects to split. Nope. I'm just going to turn off some of my things I can select here to make this a little easier. So I'm going to split that object and that object, hit enter when done. And now I'm going to select what I'm going to split it with. I'm going to split it with these. And then again with these. I hit enter and it says two curves split into 8 pieces. Now I can select portions of this. So I'm going to go in, I'm going to type a command called sweep 2. And this will allow me to rail edges together to create the chamfer sort of manually. So I'm going to grab that, 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 and that, and hit enter. See what I've done? Now I got to do the same for the others. I'm sure I could have lofted this. I'm sure I could have gone in and put a chamfer. There's, as Evan Gluck would put it, a myriad of ways to skin a cat. Evan Gluck being a consummate cat skinner, apparently, and a total weirdo.
My face is the skin of cats.
Oh my.
Perfect. This is why you're muted, Evan. So I'm just going to grab these, continue. No, that's not what I wanted to do. One of the cool things that Rhino does, and I'm not sure if the other ones do it, unable to sweep. Interesting. If you right click, it'll allow you to repeat commands. It also acts as an enter key. So I'm selecting my rails again.
Sweep them rails.
Once again, I am sure there is a much faster way to do that. So my next step, I am going to grab that curve right there. I need to take a cutting out of the top, but I don't actually have anything to cut with at the top. So I've selected that, and I'm going to type project. Now I'm just going to make it so I can select surfaces again. And I'm going to select that surface. And note that it made a copy of that curve up on the top for me to use. So now I'm going to grab this and I'm going to extrude. And this time I am going to have both sides selected. Rhino can be really funky sometimes when you're trying to do a Boolean cut, and said Boolean cut meets a face. So it will sometimes take the cut out of the middle of the thing, but leave the face untouched, and it's irritating and whatnot. So 9 times out of 10, the easiest way to do this will be to pull your shape both sides. Before I do that, I'm just going to select everything I have here that is not a curve, and I'm just going to join them. This way, when I do this cut, it'll cut out everything and not just certain parts of it and make a whole mess. And I sit here swearing for 10 minutes while everyone watches.
Nothing wrong with that.
So I'm going to extrude. I'm going to make sure I've got both sides selected. And this needs to be 5 into it, I believe. Now I've got this weirdo shape right here. So I'm going to do what's called a Boolean difference. And I'm going to select the surface I'm subtracting from. And that went poorly. I'm going to hit enter. I'm going to subtract with this. And of course, it was funky. I wonder why that did that. So I've got a hole, but it does not go all the way through.
You probably just need to extend your.
Yeah, I
Or
think I
can
just
you-
need to go in and trim.
Can you just delete those faces?
Yeah, that would be what the what the trim function works for in this situation. I'll deal with that after in a minute here. I'm gonna get the other hole on the go. So I need to grab this.
I like that it actually looks like a sketch. Looks like you could actually make a comic book with this.
So I'm gonna just drag that all the way through. I'm gonna Boolean difference again. Hit enter. I'm gonna grab that and hit enter. And I totally messed up the middle of it here. To be fair, you get the gist of what I'm doing here.
I get the gist.
Boolean difference can be awesome. It can be
Still a little buggy in Rhino.
frustrating as hell. I am sure that there is a join here that I did not do correctly. and that is going to be what has caused that.
Well,
I
don't
just
worry.
backed up, and I'll try this again at some point later.
We still got to get through Blender, and that didn't go so smooth either.
Smoother than this.
Smoother
Ian,
than
you
this.
want to give Blender a try?
Smoother than this, bro. Calmer than you. Yeah, so Blender. So I've got this set up a little bit to show kind of like, you know, a lot of what Blender is for making assets for like anything like CG, video games, all that kind of stuff. And so like a lot of what people do is like real, like you need a dog for a video game. You're going to model a dog, and the way they start modeling is to bring in reference pictures, and they put them in all of, you know, just like you would put in a, you know, a detailed drawing of a machine widget or something like that. So I've done that here. So we've got the side view here, we've got the top view here, and then whatever this view is. I went ahead and put in my numbers so that we can reference them, because for whatever reason, Blender goes off radiuses instead of radii instead of diameters, which is really annoying. Same thing up here as Fusion, and probably a lot of them, this little orbit mechanic up here. One of the things I will say about Fusion that I really like is that, why did my Fusion shut down? You've got this when you're squared off. I absolutely love these little rotate handles up here, and I've put that in the suggestion box a bunch of times for Blender. They don't have it, but you still can square off on things. So I'm going to do this. And the thing that you have to know about Blender is you just got to succumb to the idea that you're going to learn hotkeys. It's impossible to use this program without just committing yourself to the idea that you're going to use hotkeys, because there's just straight up, there's stuff that is not in the menu system that is like critical to use. And if you don't, what?
Yeah, Rhino as well. It's the same deal. It becomes really hotkey heavy almost immediately.
So just, you know, like I've never used a single Fusion 360 hotkey, probably to my detriment, although I've reached for a lot of Blender hotkeys when I'm using 360. So anyway, thing about Blender as opposed to the other modeling is this is mesh modeling. When you're in, so there's NURBS modeling and mesh modeling. NURBS modeling, like if you keep zooming in on your circle in the NURBS modeler, you're just going to keep seeing an arc. Not so in Blender. You know, everything is vertex, and then the lines to make the, you know, you've got, if you put in a circle, it's going to be a certain amount of vertices, and then the lines to connect those to give you the circle. Now, the nice thing about this is when you do a NURBS model and you export it as a OBJ or a step or STL or whatever, it's going to spit out a mesh, and you have no control over what the resolution is at that point. I bet you probably could. I've never experienced it, but you don't have any real control in my experience with what it is. So when you model in Blender, the nice thing is you can control the resolution right off the bat, and you can keep your model clean for renders. And that's a whole nother topic. But Blender, you've got two modes, object mode and edit mode. I don't have anything to edit yet, but in object mode, you've got all of this add, and there's all different kinds of things that you can add right here. We're mesh modeling, so we're gonna stay in the mesh world, and we're gonna start adding our circles. And so right here we have the choice of saying how much resolution do we want on this circle. 32 is a little skimpy. It's usually good on circles to keep it an even number. I'll bump it up to 96. But now when we go in and we toggle into edit mode and we look at this, I've got this circle selected. I'm going into edit mode up here. We see that this is our resolution for this now. If I believe it's F9 or F8. What is
It's
it?
a lot of vertices you got there.
It is, but it's making a nicer circle. So Okay, so we did that one. Go back into object mode. I'm actually going to delete that one because I've lost the numbers on it. So I'm going to do another one, circle, and then we're going to do point 295. And that's that. And then we're going to add another circle. That's going to be the point 0.20. And then we're going to add another circle. And that's going to be the 0.155. I'm going to do this a little differently than we did it last time too. We're going to do another circle. And that's going to be 0.07. And then we're going to do another circle. And that's going to be the 0.115. Okay, so we need to make some faces here. And you know what? I'm going to actually add a plane just so we can see this a little bit better. I'm grabbing this plane. So G to grab, and then it's moving all around. I'm going to constrain it to the Z axis by hitting Z, and I'm going to move it down. And that just gives us something. I'm going to change the mat cap a little bit, just so maybe it's a little bit more easier to see. Okay, so here we are. It's easy to see now. Yep, easy to see. All right. So we're actually gonna, I think we're gonna join all these circles. So I'm gonna hit this circle and then shift, 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 shift. This is the outliner over here. I could have also done it over here. So if I wanted to go shift, 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 shift in the outliner, that would get me my guy. I'm gonna go Control J to join. And now when I tab into edit mode, which you can, I'm not using vanilla Blender, so I've got some different things, but I'm going to go into the vertex mode here. And now we're seeing these circles. So this was actually acting a little bit buggy before, but there's a lot of different ways to select in Blender. So here's my selecting individual vertices. If I was to hit Shift, I could select like this. I could also box select. What I'm going to do is I'm going to hit Alt and then the edge right next to it. I should say to start off with, these are your different selection items here. So you've got vertices. If I switch to here, we would select edges. And then if we had any faces to select, if I was selected on that, we would select face. But we're going back to vertice, and then I'm going to hit Alt, and that's called a loop select. When you hit Alt, it's just going to follow around until it finds the end of something, whether it's a triangle or something that doesn't make sense with continuous lines. But it's just gonna follow that. So I'm gonna hit Shift and hit this other edge, and then Shift and Alt. Oops. What's going on? Oh, I was hitting the Windows key. I'm gonna rip that out of the keyboard, and that's gonna connect those guys. So then I'm gonna go in to the edge select here. This actually doesn't have a hotkey for some reason, but bridge edge loop, and that's made faces out of that. So I'm going to go and I'm going to select this, Shift to do that. I'm going to hit Edge, bridge edge loop again. Edge, bridge edge loop. Whoop, I didn't like that one. Yeah, it's getting buggy. Okay, so what I'm going to do is I'm going to go. Oh, I'm going to go there, go Shift and go face. And I'm going to keep hitting face, and it's actually going to face around that. I'm going to try to go back to bridge edge loop. W. I'm hitting keys a little funny. And then edge, and then bridge edge loop, and that's acting funny. I like that.
We ran into this before.
Yeah, it's the algorithm sometimes is. So this is going around. And yeah, all right. So here we are. And we've got all of this ready to go. I'm just going to take this whole kit and caboodle. And we've decided that we're going, our first step is up 0.08. So I'm going to take that whole mess and I'm going to go, oh, I had cap lock on, that's why. E to extrude. And then I'm going to go, for whatever reason, it's negative 0.08. And then my next, I'm going to go into face select. Oops, something didn't work right there. I think we got some faces that didn't happen. So you can loop select with faces. So now I'm up in face select here. You can loop select with faces as well. And so E to extrude. And then I'm going to go negative 0.08. Oops. Negative 0.08.
It's weird that it registers that as a negative.
Yeah, I don't know why, because this is positive Z and this is negative Z, but I'm sure if I was to go into it. So something funky is going on here. For whatever reason, and I think it's maybe because I'm going the opposite way, but I think my normals are messed up. So I'm not gonna go into what normals are, but I'm just gonna recalculate them to the outside really quick, just to make sure we're good to go. But for some reason, this is giving me pass through look, and it shouldn't be doing that. All right. Oh, is it because I'm in? Okay, here we go. This is better. Thank you. Okay. Yeah, something's going on with my modeling suite there. Some settings been hit. So okay, so the next one is this guy, I believe. Yep. And so we're gonna go up, we're gonna go E to extrude. And it's intuiting that I want it constrained on the Z-axis. So I'm gonna go 0.27. For some reason now it's doing it. And then my next set of extrusions are this guy. Is that right?
Yep.
And then E to extrude, and that's 0.08. And then this is where Blender gets it can get pretty interesting. So wait a second. Oh, okay.
The function you're about to show where you are building the chamfer around that is actually one of the cooler things in Blender that I've seen so far.
So I'm going to switch back into vertex mode and I'm going to do a loop select. Now, if I hit G, I'm grabbing and I can move this in any direction. I can also hit Z to constrain it in the Z direction, or X to constrain it in the X direction. The nice thing about Blender 2 is you can go shift into a constraint, and that will actually constrain it in only, it will basically invert the constraint. So if I hit Shift Z, I can move it in, oops, hold on a second, G, Shift Z. See how the X and the Y axis are still available and the Z is excluded. But so if I hit G and then I hit G again, basically what it's doing is it's constraining it to the edge. So like, for instance, if probably a better example is if I hit just this one vertex and I go GG to constrain it, it's going to let me go along that edge, or this edge, but basically what it's doing is it's constraining it along an edge. So if I do a loop select on this and I go GG, it's constraining all of those along the edge. So there's a clamp overlap too, where it's going to clamp it there, but that basically makes my my chamfer. So the problem with this though is now I've basically hidden off vertices.
Yeah, you've got two sets of vertices.
Extra vertices. There's a
standing
couple
on each other.
There's a couple ways to take care of that. One, I could tick auto merge on here, and that would just auto merge those vertices. Or I can hit A to select all. I can hit M to merge. I can go merge by distance. And then this is the distance that it will merge by. That's a very, very small amount. So everything that is next everything that's overlapping by that distance or that close will get auto merged. And if I bring that up, you can see like it's starting to like everything disappears.
Mm.
So everything is being merged into one thing. But if I just go there and then I hit G to move it, now I've got one vertex there. So that's, and then probably the next move is to take this. So we'll do a loop select, and then I can't remember what that.
0.245.
Let's get rid of this plane now. So X to delete. I'm getting rid of that plane. I'm gonna go GZ to move that image down in the Z axis. I'm gonna hit tab and then face to come in here and do these faces. And then where's this at? Where's that number at? Let's see here.
The distance in which it's supposed to recess into it.
Yeah.
Yeah, I don't think I actually wrote that for you. It's 0.245.
So I'm gonna hit G. I'm gonna constrain it in the Z axis. Not exactly sure where that came from. Oh, it's okay. So before I do that, I'm gonna get rid of these loops. So I'm gonna hit that, do a loop select X. I don't want to delete the edges, but I'm gonna dissolve the edges. And so I'm gonna come back in here, do this again. So G and then Z. Whoops,
That was neat.
it is neat. Let me see how am I gonna do this. Yeah, you know what? Let's do it this way. So what is it?
0.245.
That look right?
Yep,
Okay.
that looks right. And now are you just gonna trim?
Yeah, I'll just trim this. I'll just. One. Oh. Actually, maybe what I'll do is I'll bring this down. So I'm gonna come up here and hit no. Have a seat, have a sit down. So I'm gonna hit the I'm gonna snap the vertex. Boy, that was pretty dumb. Come on. I'm gonna snap to vertex and bring this down. G and then Z. And maybe what I'll do is I'll dissolve it there. I believe that's it.
That looks great.
So you guys wanna do some shading and some rendering?
Yeah, if you don't mind though, I'd like to go back to Rhino for just 1 second here. I figured out where I went off the rails.
Okay.
Just gonna share screen for a sec. So where I did a join earlier, what I actually should have done, and I didn't think about it, would be the opposite of a Boolean difference, which would be a Boolean union. And said Boolean union turned all of these surfaces into one surface. So now what I'm going to do is go back to doing the extrudes that I'd originally planned. So I'm going to just make it so I can select curves and not surfaces at the moment. I'm going to grab that and I'm going to extrude my curve 0.245 in both directions. And then I'm going to do a Boolean difference. And I need to have surfaces selected. So that's the surface I'm cutting out of. This is what I'm cutting with. And note, now I actually have the proper hole going the proper distance. And I'm just gonna grab that, extrude, curve. I'm gonna bring it down to where that meets. I'm gonna do the exact same thing, the Boolean difference. And there we go, all the way through. And it worked the way it was intended to. If I wanted to be a super duper keener, I could go to the McMaster car website and I could pull the screw I require to thread this, but I'm not going to do that. Back to you in Blender, Ian.
Okay. All right. So, by the way, all these windows in Blender are modular. We have the item here. And I've got the camera like locked to the view here. So if I want to like, I added a camera and the camera's here, and everything has become so small that it's actually quite annoying. So I think maybe what we'll do is we'll just scale everything up so it's not quite as annoying. For the sake of this, I don't really fully understand the scale situation, but so I'm going to hit 0 to toggle into my camera mode. This is my camera outline. I'm going to hit check mark to bring this in. For the sake of this, why don't we get rid of all this? X to delete, 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 X to delete. And then we've got different views up here. This is the rendered view, which gives you just kind of like it's a pretty bare bones rendered view. It gives you a little bit of shading and stuff like that, but it's not great. So I'm going to go GZ to move this down to make sure I've got a little bit of distance there. Get rid of this too. Come back into workbench view. So Blender has two different native render engines. One is called Cycles, which is ray tracing. Which is to say that it's bouncing fictitious light beams off of everything to make it shadows and to make its refractions and all that kind of good stuff. And then there's the Eevee render engine, which does all of that kind of stuff fraudulently. So any of your like ambient occlusions and stuff like that is going to be done not with ray tracing, but with algorithmic trickery. The thing is like this. The amount of time that it takes to render is like pretty different between the two. Like even this simple item right here, which is not, you know, super high polygon. We don't have any shaders on it yet. So in Eevee, boom, in Cycles, you know, here we go.
Wow.
Here we go. And then we got that. So the first thing to do is Cycles has the ability to use, and EV2 has the ability to use HDRIs. So there's two different areas for messing with your shaders. One is the object world that deals with this. If I was to go new, and I'm gonna get this is actually like a partial render. It kind of just like gives you an idea of what your materials actually look like. So if I was to change this to something like black, black, you would see it immediately right there. But so we have the world view too, which is this this 360 view of this workshop here is an HDRI. And so when you're rendering, that's the light that's being bounced off of this item to make this render happen. And you can get different HDRIs and plug them into here. And this is one of the reasons why this render is going to look a lot better than a Fusion 360 render, is because you can actually get real world lighting to give you that look. So here I've changed that to this scene here, which is upside down. But if I go Control T, I can add controls to this HDRI, and I can do things like I can rotate this in the Z-axis and flip that around to the right way. So now I'm going to hit this and scale this, my backdrop up, and then we'll come back into the object mode, and let's do a couple interesting things. We'll give this a color. Let's make this green. And then, so this is called the principled BSDF. And this can handle all different kinds of material situations. You want it metallic? How metallic do you want it? You slide that up. You want more specular highlights? You want less specular highlights? You want to up the roughness? You can do that. But you can also do really interesting things with this. You can add textures. So let's say we have a brick texture. And if I was to add this into here to the color, this would give us our brick texture like that, right? But
that's neat. I like that.
And then we can change the color of the brick or whatever. But for the sake of this, what we'll do is we'll keep this black and white. What you can do is you can move your brick texture into any of these items, and basically everything about how any of these things are controlled is, you see here, it's got a value of 0 to 1 here. So white to black and all of the grays in between also function from 0s to 1s. And so when I take this brick texture and I put it into the roughness, basically what's happening, we'll go ahead and go to render view. But wherever it's white, it's rough. Wherever it's black, it's not rough. And so when we render this, let's change this back to something more like let's see here. And if we were to take that and like throw it into maybe metal too, this might actually be not a very good.
This seems like there's a lot more control than both Fusion and Rhino when it comes to rendering.
Oh yeah.
Yeah. I mean, Rhino has an abundance of swatches that you can use for.
Oh yeah. Oh no. This is completely different. So that wasn't a very good example, but so here I've switched to this object here. And the other thing that you might want is you might actually want a texture. There's a couple different ways to do a texture. One is you can do a displacement. You need a lot of geometry to do displacement because it's actually displacing the geometry. And so if I was to bump up the vertices on this, I could use a displacement. But there's a cheater way of doing things that involves a bump, what they call a bump map. And this is another just kind of algorithmic way of dealing with this. So I'm going to stick that into the normal, but we need some values for this because right now it's only the strength and the distance. We're only doing that. So if I come in here and I grab a noise texture and take that color, this one comes out black and white. So if I throw that into the height, I believe, we get that. Now I can throw this into, sometimes it's best to throw this into the base color so you can see what you've got. But right now that bump map is like, it's super duper big.
Yeah.
So if I do this image render here, we've got the image and the bump, so it's probably going to look a little funky. Yeah, let me take the image off of that. What it's doing is it's generating, and we'll bring this up to kind of like a gray. It's generating fake shadows for a bump. Not super compelling, not as good as the displacement. But when you take this and you tune it down, if I go Control T off of this, this is giving me all of these controls for this guy. And so I can take that bump and I can scale it down. There's also scale in here too.
It's amazing watching the computer actually try to generate it in real time.
Yeah, I've got it set pretty low. This should give me it won't give me that there. But now we're starting to get like starting to bring it down into something a little bit lower. And this is like if you were to try to make something that was like looked a little bit worn, you can do it with a bump map like that. So, and that can look a little uniform. And so what you can do is you can come in here and do a color. So all of this is color. So you can actually mix color. So if I wanted to do a mix RGB, this would actually be it's different algorithm, or it's different mathematical equations, but it's taking those values and either adding them, subtracting them, having a difference or whatever, and then the factor between the two things. So I could come in here and instead of a noise texture, I could add say a Musgrave texture, throw that in here like yo. And you can see that it's starting, you can see that there's like a different texture being added to that as well. So there's two textures going on there. This texture and this texture. And how I add and subtract those or do a difference is going to affect what that winds up looking like in terms of a bump. So like mix is probably the one that gets used most often, but multiply can work pretty good. And then the thing is this factor, you can actually throw a texture into that too. So if I go to add and I go to texture and I want to have a brick texture, if I were to throw that into the factor, then instead of it being one way or another, basically anywhere where it's white, it's probably throwing the Musgrave. Anywhere where it's black in the brick texture, it's throwing the noise texture. And so you can do some pretty interesting things based on this. Brick is probably not super useful. But that's kind of it in a nutshell. You play around with this until you get things how you want to look. So this is procedural texturing and shading. There's a whole world of there's a whole different world of shading and texturing that has, you basically have maps for things. So if you wanted the texture of a rock, you would go and get a texture pack from, like there's a bunch of free ones online, and it would have like have a UV, it would have like a normals map that would give you your bump texture, and you would have like an image texture that you would throw on there. So like, for instance, like if I wanted to, like any of this stuff, if I go Control T and throw that on there, like I can throw, let's see here. Just give you a, So here's the old IHG logo, which is
Yep.
actually a PNG. But you know, you can do interesting things with this too. So that black and white and gray image could be used, you know, the same way. Like I could take that color information and throw it into the metal, and like certain parts of it are going to be metal and certain parts of it are going to be not metal based on that. It's a little close, but if I throw that also into the roughness, then you can see like we've got something where we've got like a mirrored image and then a not mirrored image. So you can bang out Coke mirrors pretty effectively.
What Blender was invented for.
Yeah.
Uh,
So, but you can see like this is mirrored, this is not mirrored, and that's based off of this going into the BSDF, like in here. So, and as far as I know, with those procedural textures, and if you want to watch a guy who's a real amazing artist with both geometry nodes, there's a guy named Arundel who's an absolute freak with nodes. He gets, you know, like it's not uncommon for like if you're going for photorealism to have, you know, nodes stretch, you know, in these crazy trees. Like what I was doing there was very basic, but you can get to photorealistic things pretty readily. So
before we wrap up, does anyone have any questions about Rhino, Fusion, Onshape? Anyone who's left?
we could. Do you want to see the thing that I threw something into? This is very fast, but I thought this might illustrate. Do you mind if I do one more thing?
No, go for it.
So this is a part that I modeled all of this stuff in Blender, and just so you can see, this has this lip out here, and now that I saw Brett do the loft, I probably realized I was just kind of more Blender focused, and so I threw it in Blender, but this probably would have worked fine with the loft. Although there are some things that you can do in Blender that I think are a little bit more interesting. But the so this, I needed to have that thing to keep it stuck into the thing there. So this is how it came into Blender. And once again, like it's got a lot of weird geometry. If I had modeled this in Blender, we wouldn't have like these weird items in here. Oh, I'm not sure on screen.
Yeah, you're gonna want to share screen.
Okay. So so basically what I'm going to do is I'm going to hit K to cut. I'm going to take this line and I'm going to hit X to constrain it to the X axis. I'm going to hit C to make it cut through. And then I'm going to hit enter. And basically that's made a line that goes all the way around it like that. And so I'm going to come in here and grab these guys and just grab these faces. And then I'm going to go T to bring up the toolbar. And I'm going to go extrude along normals. And basically what that's going to do is it's going to extrude those faces outwards along normals. I won't get into normals, but just know that every 3D object has normals, and it basically says, hey, this face is pointing this way instead of this way.
Yeah.
So I'm going to grab these guys. I'm going to go back into the select mode. Let's see here. I just toggled on X-ray mode. So a lot of Blender is just completely about selecting, like learning how to select. So once again, let's try GG in. And we got our clamp overlap. And then if I wanted to, I could go Uh,
You're hitting Alt to select.
yeah.
I really need to spend a little bit more time with Blender.
And then this, I can scale these guys out too if I wanted. That's maybe a little shift actually brings in your thing, and this wound up being I'm a little close to this is I think screwing up based on the origin point. But you can hit S to scale. And you can once again you can constrain it like in the X axis, the Y axis, or the Z axis. Or you can probably more interesting hit Shift Z, and then you're only scaling out like that. So you could, if you wanted that to protrude a little bit more. But I find that to be pretty easy.
Neat. Mike
Yeah.
Brower, you kind of snuck in there. Do you want to give us a run through in AutoCAD on some of this, or are you gonna politely decline?
I'll politely decline. I'm so embarrassed. I forgot all about it. And Doug Proper sent me a text that was very politely, "Where the fuck are you?" I was out in the alley, so I'm behind the house. So, geez.
What was going on out there? Fun stuff.
That's where the wood shop is out there.
Oh, I thought you were gonna say you're smoking weed with teenagers or something.
Yeah. Just bought them a 6-pack.
Not today.
All right, my wife just got home, so
All right.
I should probably go.
Well, I guess
Robin,
that
this is a good 3D club. And Brett, if you're interested in more rendering and Blender, you can totally. One of the things I'll say is you can throw models out from Fusion 360 and import them into Blender, but just know that Fusion 360, when they don't spit out models that are really ready for prime time when it comes to rendering, because you have a lot of artifacts, because they do a lot of triangles.
Okay.
And modeling for render is all about keeping things quad. There are things that you can do to go in and clean them up, but there's a lot of cleanup to do for good renders in any of these kind of situations. So
Cool.
Before you go, Ian, I just wanted to double check with you. I may need an OBS lesson, but I got the recording, but something very strange was happening, that every time somebody went to share a screen, the entire justification of it shifted on the screen, and I kept having to recenter it. And I was able to just sit behind the desk and do that every time for the most part. But I don't know how to keep it from doing that.
I ran into that with OBS as well, actually. I wouldn't mind getting that figured out. I was trying to record some of my own Rhino stuff.
Hold on 1 second. Let me see.
Well, this can be done outside of 3D Club.
Yeah, have you
thank everyone for joining here and demoing and whatnot. That was
somebody. Thank you. Really good 3D Club, by the way, Robin. Well done.
Yeah, I didn't understand a word of it. It was awesome.
Can somebody,
Doug.
Robin, can you share a screen really quick?
Yeah.
Of something Rhino related. My OBS, I think, is no. Yeah.
Did it automatically try to resize it?
Yeah, it resized it.
And then when you go back, it changes it again.
Yeah. Okay.
Yeah.
I'll look at that.
Are you gonna have questions or not?
Oh my God, absolutely. If you've got a question, let's do this.
Okay, Robin, on the piece you were working on, you were using Boolean difference. Couldn't that be done with the whole command?
The whole command in Rhino?
Uh-huh.
I have never used it.
because I think, well, that's how I got the actual holes for the on the headstock of the guitar.
Yeah.
It works on any surface.
Yeah.
So it's kind of like extrusion, and then you say, well, this is going to be a hole, and Rhino knows that you need a hole there.
Yeah. Honestly, I'm just going by the way I was taught to use it, and the bulk of what I was taught was using Boolean differences and whatnot. Almost never using the patch command. Always using sweep over patch or a network mesh. So
Yeah, well,
once again, like there's a lot of ways you can do this stuff in each of these programs.
maybe because I learned from a designer that works mostly with furniture, and I guess it's easier for some of the furniture stuff to use the hole command. So yeah.
I'll go and play around with that at some point in the next couple hours, probably just to test it and see if it works better than Boolean difference in certain scenarios and whatnot.
All right.
Anybody else? Perfect. 3D Club is over. Toodles.
Thanks, Roland. Good stuff.
Thanks, guys.
Everyone for joining. Brett, I would like to hear a little
Thanks,
more.
Robin. Thanks for setting it up.
Yeah, it's no problem.
Cheers, Jamie. Cheers, Brett.
Yeah.
All right.
Yeah.
Final question. Can you start over?
Miguelito.